right. So this week we're not gonna it's not gonna be a very challenging week. Hopefully, it's gonna be a review of what we covered last week more than anything. When I talk about positive and negative intervals, I think that's the only new thing that we will cover. And next class we will kind of like combine everything together and kind of wrap up, linear functions, especially when it comes to graphing and understanding how the x and y intercepts work. So this is not going to be a very busy week. I know that some of you are running behind, so it will also give you the opportunity to catch up. And on Friday, there will be a quiz, but it will be more of a survey than anything. Okay, so it's gonna be like a multiple choice questions. I'm kind of feeling a little concerned about some of my students, so I need you to share some feedback with me in terms of how the course is going, how the other classes are going, and if the workload is reasonable and stuff like that. So please share that with me on Friday. But for now, let's just I guess proceed with today's class. So determine the x-intercept. Okay, so this might confuse some of you because usually, what you have is the function is always written in this form. Y is equals to mx plus b. And then you can solve for your x-intercept. Remember, x-intercept means that your y value has to equal to 0. Okay, that's what x-intercept means. Okay, so x-intercept means y has to be 0. Why? Because if you graph a function, I'm just drawing a random linear function, right? Let's say this is x, this is y. This is your linear function. Let me do that in a different color to illustrate my point, right? Your x-intercept happens when your function crosses the x-axis, so it's this point. And as you can see, this point has some x value, but the y value of this point will always have to be 0, okay? So that's where the y equals to 0 comes from. Okay, so there's many ways of solving it. One way would be to put this into this form, and then replace y by 0. Or what you could do is you could just work with this equation that you're given and replace the y value by 0 right from the beginning, okay? So you don't have to really put it in this form. I'm going to do it both ways, I guess, but what I'm trying to tell you is that remember, x-intercept means that your y value has to be 0, right? So what if I rewrite this equation? So it's going to be 5. Instead of y, I'm going to put 0, right? And then minus 10x plus 30 is equals to 0, right? So all I did is replace my y value by 0, right? Which is what the definition of an x-intercept is, right? And then all you have to do is just solve for x. Okay, so 5 times 0, right? If you're not sure, it's 0. Um, but when you're not sure, always use your calculator. But remember, whenever you multiply anything by 0, it vanishes. Okay, so you just get 0 back. So this becomes, right, this simplifies to minus 10x plus 30 is equals to 0. And now your goal is to solve for x. So there's many ways of doing it. You could, get rid of the 30 if you want. Okay, so let's just do it this way, minus 30 and then minus 30. So this disappears. So that leaves you with minus 10x is equals to minus 30. And then you can get rid of the minus 10, right? It's minus 10 times x. So the opposite is divide by minus 10. Okay, so divide by minus 10, divide by minus 10, and then your minus 10 disappears. So x is just equals to 3. Okay, so this is your x-intercept. This is one way of doing it. Okay, um, so let's just I guess actually let me just separate this way. Okay, so let's call this method 1. Okay, method 1. And now let's do method 2. Method 2 again. Method 2 would be what I would do if they asked me to graph the function, right? Because remember, to graph the function, you have to put it in this form. Okay, it makes it very easy because then you have your slope, you also have your y-intercept. Okay, everything is given to you, but that's not what the question is asking. But I'm just gonna do this for you anyway. So I'm gonna move the minus 10x to the other side and the 30 over to the other side. Okay, so I'm gonna have 5y still on the left side, minus 10x goes to the other side to become 10x. and then plus 30 goes to the other side to become minus 30, right? Remember, when you're moving things over, you're changing the signs, and if the moving business, you're not really comfortable with that, then, basically what you have to do is just do plus 10x and then minus 30, and then do the same thing on the other side. Okay, plus 10x minus 30, and then this is what you're going to get. Okay, so doesn't matter how you do it. Now the next step is to solve for y, right? So I'm going to have to divide by 5, and then I have to divide the whole thing by 5. So y, which will leave me with y, because 5 and the 5 will cancel, right? So y is equals to, now you have to divide the 10 by 5, which gives you 2. Okay, the x remains, and then don't forget to divide the negative 30 by 5, which will give you minus 6. Okay, and to solve for the x-intercept, so this is the form y is equals to mx plus b. Okay, so I've put it in this form, and it's again the it's usually a good thing to put it in this form because you know it becomes easier to graph. That's not what the question is asking, but like I'm just just mentioning that, kind of like a side note. Anyway, now the next step is to replace y by 0. Oops, to replace y by 0, right? So I'm going to replace this by 0 and then solve for x. Okay, so again, let's just do plus 6, right? On both sides, plus 6, plus 6. The 6 disappears, and then you're going to get 6 is equals to 2x, and then finally you can divide by 2 to get x is equals to 3. Okay, so this is your x-intercept, right? Same thing. And if I were to give the coordinates, right? So this is the point where my x value is 3, but my y value has to be 0. Okay, so I guess this picture over here, right? Now that I have my graph, I can actually quickly sketch this, but this picture not does not represent this function. Okay, so what my picture should look like is, again, I just gave you an example of what an x-intercept was, but if I were to quickly sketch this function, right? Remember my functions, right? The y-intercept is -6, so it starts in, right? -6 is over here, so maybe let me use the green color, right? So somewhere over here, and my x-intercept is 3. So my y-intercept is -6, right? It's coming from here. My x-intercept is 3, right? So I'm going to put a dot at 3 and then just connect this, okay? And this is not the, so something like that, okay? So this is, this kind of makes sense because remember your slope is 2, so your function is supposed to increase, right? The y values of your functions are supposed to get bigger and bigger as your x values get bigger and bigger. Okay, so your function is rising. Okay, so that would be what this sketch would look like. Okay, and if you want, I can put the points, even though that's not what the question is asking. I'm just doing this for you. Okay, so this is the point when x is 0, y is -6, and this is the point where x is 3 and y is 0. Okay, so this is your x-intercept, but I've given you a lot more information than it was required. Again, this is just to review what we did last week. Okay, so for today's class, we're gonna again talk about the x-intercept. Remember, x-intercept is when happens when y is equal to 0. Okay, right? So just like in the starter question, sketch a graph and determine when are the function values, when are the following functions positive or negative. Okay, following functions because there's actually 3 of them. Okay, so let's find the x-intercept. Okay, how do you find the x-intercept? Right, replace y by 0. So 0 is equals to 2x minus 3, and then just solve for x. Okay, so plus 3, and then you get 3, right? Because they will cancel out. So 3 is equals to 2x, and then you have to divide by 2, and then divide by 2 on both sides. So now the 2's will cancel. So that means that x is equals to 1.5. Okay, so that's my x-intercept. And then it's asking me to sketch, right? Sketch the graph. So that means I know my x-intercept happens at 1.5. So I have a coordinate, right? I have this coordinate 1.5, At 1.5, my y value is 0, right? I have this function over here. So using, remember, y is equals to mx plus b. I have another point, right? Namely the y-intercept. So I know that my slope, right, my slope is equals to 2, and my b value is equal to -3. So this gives me another point, right? And the other point is at 0, when x is 0, my y value is -3. Okay, so I can use these 2 points, right, to quickly sketch my function. Okay, so this is my y-intercept, okay? And using the y-intercept, I can, find the coordinate, because remember, y-intercept happens when x is equals to 0. Okay, so this is the definition of y-intercept. Now this here is my x-intercept, okay? X-intercept. And using the x-intercept, I have another coordinate. So let's just quickly sketch the function, okay? And I'll talk about what I mean by positive and negative, okay? So let's quickly sketch the function. So at 0, my function is at -3. Okay, at 0, my function is at -3, right? Using this point. And at 1.5, my function is at 0. Okay, I'm not graphing, I'm just quickly sketching. So I'm not gonna, how should I say this? I'm not gonna scale my x's, okay? I'm neither the x nor the y. So maybe I should put the x and y. And then just connect the dots, okay? So again, this is what the function looks like, and it kind of makes sense because my slope is positive, so that means my function should be rising, right? So this kind of makes sense. Now, the question is, when is my function positive? Okay, so what do we mean by positive? I haven't really defined positive because I'm going to define it by giving you this example. So by positive, we mean, so you know what? Let's just label the points as well. So this is the point 0, right? My x value is 0. My y value is -3. Let's not put the coordinate. Let's just put let's just, oops, it's not what I wanted to do. Okay, so this gives me my y value. So my y value over here is -3, and this over here gives me my x value. My x value is 1.5. Okay, so if you want, you could put the coordinates, right? 1.50, and then -3, 0, -3, but I'm not going to do that. I'm just going to put the x and y value, and I'll show you why in a moment. So what do we mean by positive? Okay, so positive means when the y values of my function, right? So we're talking about the y values. Okay, so this is what we're talking about, right? The y values. So when are the y values of my function positive? In other words, when is my function above the x-axis? So this is where my function is positive, okay? So I'm gonna put a plus sign for positive, okay? My function is positive when it's above the x-axis, right? When my y values are greater than 0. Okay, so over here my function is positive, okay? So let me clean this up a little bit. So this is where my function is positive, but you're gonna have to answer this question in terms of the x values, okay? You're gonna have to look at the x values. So the question is, for what x values is my function positive? And the answer is, right, my function is positive, right, when the x values are greater than 1.5. Okay, greater than 1.5. Why greater? Because look, 1.5 is over here, and you're moving on the right side. Okay, you're moving and right towards the right, which means that at 1.5 your function is positive, at 2, at 3, at 4, okay? And one way to kind of like check that is if you plug in a value in here, an x value that is greater than 1.5, your y value will be positive, okay? So if you put, let's say, x is equals to 2, and 2 times 2 is 4, 4 minus 3 is 1, so your function will be positive as long as your x values are greater than 1.5, okay? Now for negative, um, it's It's a very similar idea, right? So for negative, what color should I use? Let me just go with let's go with blue, okay? So my function is negative down here, right? So the y values of my function is negative down here, okay? So again, you have to answer this question in terms of your x values. So for which x values is my function negative? So my function is negative here, right? So this is 1.5 and I'm moving in the left direction, right? So that means my function is negative as long as my x values are less than 1.5. Now, here I'm not going to be picky. If you put less than or equals to or greater than or equals to, it is fine. Um, because eventually you'll see definitions like strictly positive and strictly negative where you don't have to put this equal sign. But in this case, if you put an inequality instead of like a strict inequality, it's fine. Okay, so it doesn't really matter. But I guess just to be consistent, we're just gonna put greater than or equal to and less than or equal to. Okay, so I hope this is kind of making sense. But I'm gonna do a couple of more examples and your homework questions will be assigned from the notes. Okay, so please look at the questions from here. I'm gonna do these questions separately. Once I'm done making the videos, and I'll post them for you to have a look at. French immersion students, make sure you're looking at the French notes, okay? Because the definitions are well, positive and negative is the same in French, but like the words like x-intercept, y-intercept, they're completely different. Okay, so now let's do the second question. Okay, so um, okay, I guess before we do the second question, one thing that I'm going to point out when it comes to positive and negative, the point that is really important is this one, okay? And this, right, is your x-intercept, okay? So the x-intercept will determine, it's kind of like the threshold, okay? So it separates the positive from the negative because the x-intercept is the point where your function is equals to 0. So x-intercept is what you should really be looking for, okay? When you're sketching, you can use the y-intercept, okay? So this for the second question, I'm going to do this a little differently, a little faster. Okay, so let's quickly find the x-intercept for this function. So remember, x-intercept, right, means that my y value has to equals to 0, right? So let's find the x-intercept. So 0 is equals to minus 4x plus 20, okay? Now, you have to solve for x, so you have to do minus 20, this disappears, and then you get minus 20 is equals to minus 4x, and then you have to divide by minus 4, divide by minus 4, so that gives you the x value. So this cancels out, right? So x is equals to 5, okay? So this is my x-intercept, okay? X is equals to 5 is my x-intercept. Now, if I were to quickly sketch this function, right? I know that my slope, right? Remember, if I compare this to mx plus b, that means that my slope is equals to minus 4. Because it's negative, my function should be decreasing, right? And my b value, the y-intercept, is 20. Okay, so if I were to quickly sketch this function, okay, this is what needs to be done. So this is my x, this is my y, right? My y-intercept is 20, so my function's, this is the point. Maybe I should use a different color. So this is the point, where my y value is basically 20. And because my slope is negative, my function will decrease, right? So my function looks, actually, you know what? My function looks something like this, okay? So something like this, let's say. Um, and this is the point, right? This is my x-intercept. So this is the point, it's this point over here, right? So x is equals to 5. And this is the point where y is equals to 20. Okay, so this is a quick sketch, okay, of the function. Now the question is, when is my function positive? When is it negative? Okay, so positive means, now let me be consistent with my color. So positive means when it is above the x-axis. So this is positive, okay? but the question is for which x values is my function positive. Okay, so like it starts at 5, but it's moving in the left direction. Okay, so my function is positive, right, when my x values, because it's moving in the left hand side, are less than or equals to 5. Okay, so if I pick x is equals to 0, my function will be positive. My function will have a positive y value. If I pick x is equals to -2, my function will have a positive y value. Okay, that's what positive means. Okay, so in a similar fashion, my function will be negative when my y values are negative. So this is where my function is negative. Okay, the y values of my function are negative here. But for which x values are my y values negative? For all these x values, right? For all these x values, my function is negative. So it starts at this point and it's moving in the right direction. Okay, so that means my function, I'm just going to put this symbol for negative, right? As long as my x values start at 5 and are getting bigger because it's moving in the right direction. Okay, so x has to be greater than or equals to 5. I hope that is kind of making sense. Okay, so remember, positive means when are the for which x values are my y values positive, right? So the answer will always be expressed in terms of x. Okay, so you look at your y values first, right? In the graph, you look at your y values first, and then ask yourself for which x values are my y values positive. Okay, and then your answer will always be expressed in terms of x. Okay, not in terms of y. Okay, not in terms of y, in terms of x. Okay, so I hope this is kind of making sense. So let me do one more example. And if you have any questions, please send me an email um, so that I can address any questions that you have right away. And obviously, I'm going to be holding office hours on Thursday as well. Okay, so this is a tricky function. Okay, so let's compare this function to y is equals to mx plus b. It's actually the easiest linear function that you can work with. Okay, so if you compare this to y is equals to mx plus b, let me just write this a little nicer. Okay, mx plus b. You can see that your b value is equals to -7, right? Your b value is -7, but you don't have any x's, okay? That's because, okay, when you have something like that, that's because if I were to rewrite this, this function is actually 0x minus 7. But because it's 0x, this kind of disappears, which only leaves you with -7, right? So that means my slope is equals to 0. Now, I've done this last week, right? When your slope is equals to 0, that means you have a constant function, okay? So constant function means that it's neither increasing nor decreasing. So it's a flat function, not content, but constant. Okay, so constant, or if you want flat function. Okay, so in other words, if I were to graph this function, this is what my function will look like. It's not changing. Okay, so it's flat like this. Okay, it's not going to increase, it's not going to decrease. Okay, so my b value is -7, right? This is the point -7, and I'm neither increasing nor am I decreasing because my slope is 0. So it's always going to be -7, okay? So y is always equals to -7. I'm going to put -7 over here. Now this is your function, okay? So actually, you know what? Let me draw this in a different color to illustrate my point. So let's just stick with green, okay? So this is the point, and then basically this is what my function looks like. Okay, so this is -7. Now, right, so y is always equals to -7, no matter what the x value is. Okay, so this is a very ugly looking y, so let's make this look a little nicer. Now, the question is positive and negative. Now, okay, you have to find the x-intercept. Okay, so remember x-intercept. So um, x-intercept means when my function is crossing the x-axis. So if my function, let's say if I drew a different function that looked like this would have been my x-intercept. It's the point where my function crosses the x-intercept. Okay. Now by looking at this graph, okay, ask yourself, is there really an x-intercept? Right? My function is flat. It's never changing. Will it ever cross the x-axis? No, it wouldn't. Right? But what happens if you try to find the x-intercept using algebra? So remember, x-intercept, right, means that y has to be 0, right? X-intercept by definition means that y has to be 0. So if I replace y by 0 in my function, then I'm going to get 0 is equals to minus 7. Right? This is a contradiction. Right? 0 can never equals to minus 7, right? This is a contradiction which tells you that there is no x-intercept, right? So there's no, maybe I should say, there is no x-intercept, okay? Right? Because you have this contradiction over here. And graphically, you can see why there is no x-intercept, okay? So because there's no x-intercept, that means my function will either always be positive or it will always be negative, okay? So let's think about it. When is my function positive? When is my function above the x-axis? When is my function above the x-axis? When is it over here? It can never go over there because it's a constant function. It will always, my y values will always be minus 7. Okay, so they will always be negative. So that means that my function is, when is it positive? You can just say never. Okay. When is it negative? When are the y values below the x-axis? All the time, right? So it's always negative. Now, in math, always and never, have a special notation. So always means, like in math, if you put always and never on a quiz or on a test, I'm going to accept it. But like, I just want to point this out. So always basically means when x belongs to the real numbers. Okay, so that means for any given number, pi, 0, 1, whatever x is. Okay, if x is 1, my function will be negative, right? So if x is 1, my function will be negative. If x is 2, my function will still be negative. If x is somewhere over here, let's call this pi, right, which will be slightly greater than 3, but less than 4, less than 4, okay? Even when x is pi, my function is negative. So that's why we have all real numbers, okay? But you could say always if you wanted to. Now, never in math means an x belongs to an empty set. Okay, so this is the definition of an empty set. That means like, belongs to an empty set means that x just, doesn't, like x is not taking any real value. Okay, it just belongs to an empty set. So no x values make my function negative. Okay, these are some notations for you to, think about if you want. But I'm still gonna accept never and always. Okay. So that is it for positive and negative. I hope this kind of made sense. What I want you to do is I want you to work with these 3 examples. I'm going to attach my notes with the solutions separately. So everything that I've done in this class will get attached on a PDF document. Along with the homework solutions. Okay, so I'm just gonna not make my video too long. Okay, so I'm gonna do the homework questions separately. If you have any questions, please send me an email so that I may help you. Okay, so but for this class, I think this is it. And again, remember, there's gonna be an office hour. I'm gonna be holding office hours on Thursday. And on Friday you have to do a quiz, but it will be more of a survey than anything. Okay, because I need some feedback because I'm a little worried about some of my students now. Okay, so please do that, um, or else you're gonna be marked absent, right? Because I need to see some form of engagement from my students every week. That's not coming from me. That's coming from the principal. So please make sure you do that survey. But that is it for today. You guys have a nice day, okay?